Greeting to our lab lecturer, Dr. Muhammad HAFIZ. We are from section 3 and group 3. So right now, we will present to you lab 1, which is the calibrations of level transmitter for level measurement. So firstly, I will introduce my team member and me myself. My name is ENDTHYANA JANIS and my matrix number is CE180032. And the next one is FARAH NAJIHAH HASSAN. The matrix number is CE180071. And the last one is ILIEANA BINTI Muhammad ILIAS. The matrix number is CE180089. So right now, I will proceed to the next part for this lab. So right now, I will proceed to the first step for this laboratory. So the first one is we need to do the circuit for this lab. So as you can see here, the first thing is we need to do the simulations by going to the Simulink. And then we need to choose the blank model. But because I have done it before, I just proceed to the lab 1, my previous file. So right now, for the first component, which is the repeating sequence there, we need to find it in the library browser, Simulink library browser, which is the first one is the tank for the tank liquid level, which is the repeating just there. Repeating sequence there. We can find it in the recently used. Alright. So as you can see here, so this one is it. This is the first component that we will use for the tank liquid level. Just this one. The first component already here. So the next one is the transfer functions. As you can see from the lab instructions, you can see there is we will use the two transfer function. Two transfer functions, you can find it here also. So to make it easier, we just copy and paste it here. The next one is you can see in this lab we will use the product. The next one is the calibration gain. You can find it here again. Again, or also we can use the constant for the calibration gain. So the next one is we also have the next thing is the constant, which is for the initial condition. We just copy in here. Right. The next one is the minus. We also use this one for the minus. So we can choose this one. And then we will change it later. We can change the symbol. Yeah. Double click this one. And you can see that we need to have the plus and negative sign. Plus and minus sign. Just apply it. Alright. And then for the output, we need to have scope. And also for the zip out, which is for the to the workspace. And also the scope. Alright. We have chosen the component here. So the last thing is we need to combine it. We need to connect it. Put it here. Right. So do the connection here. This one. So this one is going through here. So I'm going to here. Going to the negative sign or the minus sign. Oh. Actually, we also need the bus connection, the bus vector for the output part, to connect the output part. So we put it here, right? Going here, and then this one going here, and then the output, the scope, will connect it also to the SIM out. So for this one, we also need to change it. As you can see here, for the denominator is 20x plus 1. So just put this one to 20, apply, and okay. And then for this one, for the numerator, we need to use the the value is 1.03. And then for the denominator is 20.3s. 20.3s. Then we need to apply it. Alright, for the product, okay, we don't need to change anything. So for the calibration gain, this one we need to put it 0.8. For the initial condition, we need to change it to 0. Right. So so the thing is, we also can change the name of the component here by clicking it twice. Just change it for this one, you can change it to the tank liquid level. The second one is the reference for the level measurement. For the level measurement. This one is for the level sensor. This one is product, right? So this one is the calibration gain. Calibration gain. Inspect. So this one is the initial condition. So I have completed the circuit for this lab. I will pass the next part to my team member.
Assalamualaikum and hi, my name is ILIEANA binti Muhammad Ilyas, metric number CE1800889. So now I'm going to continue my friend's presentation for our lab 1, which is for the part A. So we have set up our circuit, which is proceeding with level click, and then the vector of output values is 25, 5, 30, 40 and 25. While for the sample time we set to 200. Click OK, and then the initial condition we set up the constant value of 0 and the sample time INF. So click OK, and then we have right click. We have click on the MOHD configuration parameter with a minute, and then it will appear setting for the simulation time and for the solver selection. So the simulation time we start from the 0 and the stop time is 1000, and then the solve selection variable step and ODE 45 common prints. So the max step is start from 1. The max step is 1 and the minimum step size is 0.01. The relative tolerance is 0.001 and the auto absolute tolerance for the initial step size is 0.1. So we click the OK. And then for the part A, we have to click on the calibration gain, which is 0.8 for the constant value, and the sample time will INF, which is inf. And then next is I'm going to pass to my friends to show their graph response and the calibration. Thank you.
Hi and Assalamualaikum, my name is NAJIHAH binti HASSAN, CE18071. So I will continue the presentations for lab 1 part B. So the first thing first, we need to change the calibration gain value into 1, and then we need to run. Then we can get the response graph, which is like this and slightly different with part A. And then we can get the signals for 1 and 2, which is we need to to get the experiment data for level reference data signal 1 and level measurement signal 2. So all these values slightly different between signal 1 and signal 2. So, and then we need to calculate the error, and for calculation gain value 1, we can get error all negative, but in part A we get the error all negative, all positive. So what we can see from the results, we can see if we put the value of calculation gain is 1, the value of error will be negative compared to the value calculations gain if we set as 0.8. So that's all for me. Thank you.